Example 5. Consider pulling water from a 20-meter well using a 7 kilogram bucket and a rope of negligible mass. At the bottom of the well, the bucket contains 60 kilograms of water but reaches to the top with only 40 kilograms of water. If the water spilled from the bucket at a constant rate, how much work is done? Again, here two things are going on. The empty bucket is being pulled and the bucket filled with water is being pulled. So the total work total equals to work bucket plus work water. And work bucket is our case 1, which is constant force. And work water is case 2, which is force as a function of x. And we know that it is the linear function because the water is spilling at a constant rate. So we can set the integral for work bucket, integral from a to b, which is from 0 to 20 because it is pulled up to 20 meters. And the mass of the object, which is empty bucket, which is 7 kilogram. But here we have to consider gravity as well because this is metric system. So we have to multiply 7 by 9.8 dx. So this is our gravity. And this is the mass of the bucket or weight of the bucket. Plus, now we have to calculate the work water. Again, integration from 0 to 20, we need to find the linear function. At the beginning, our water is 60 kilogram. So this point is 0 to 60. And then when it reaches to 20 meters, our water is 40 kilograms. So this point is 20, 40. And our linear function visually will be from this point to that point. Now we need to calculate the slope here. So slope is delta y over delta x. Delta y, which is y2 minus y1, this is our x2, y2, x1, y1. So y2 minus y1 is 40 minus 60, and x2 minus x1 is 20 minus 0. So 40 minus 60 is negative 20, and divided by 20, so our slope is negative 1. So our function is y equals to negative 1x, which is negative x, plus y-intercept, which is 60. So this is our force as a function of x. So our integration from 0 to 20, negative x plus 60 times gravity, which is 9.8. Again, we have to consider gravity here because our weight is in metric system, which is kilogram dx. So this is how we set up the integrals, and when we calculate these two integrals separately and add them up, we find the work total. And the answer will be in joules or Newton meters. So I would like to leave after I set up here. This is how we set up the work here. Let's go to the next example.